Today's Thursday, not Friday, and we're getting into lesson 6. And lesson 6 is going to bring some fun, because in lesson 6 we're going to be drawing sets. Sets are just a fancy, I don't know if set is a very fancy word, but set refers to a group of images that represents different expressions. What we're going to be doing with these sets is that, really they'll look like arrays. So very like precise rows of triangles or circles or apples or hearts or something. So we'll look at a set and then we're going to identify, trying to make this look like a rectangle. Then we're going to identify various fractions within our sets. So we're going to start off really, really simplistically, as we do with anything that's new, and then our sets will become more complicated and our fractions will become more complicated. I think you guys will enjoy lesson 6 because it involves some drawing and really just looking at things visually, and what we're really identifying, what we're really investigating and exploring here in lesson 6 is, what does it mean to find a fraction of a whole number? What does 1/6 of 12 look like? What does 1/3 of 15 look like in terms of the images, and then in terms of like your final answer? So let's look at some examples here. Here we go, guys, jumping right into lesson 6. Okay, so here first let's look at 1/3 of 6 and 2/3 of 6. In order to check that out, we first need to draw a set. And like I said, a set is just going to be an array that shows the amount that we're working with. So here, the amount that we're working with is 6. Notice that my 2 rows consist of the same number in our denominator. So I'm just trying to be very thoughtful with how I'm arranging my sets. So I have 6 chocolates here, and I'm looking for 1/3 of 6. Well, do you guys see how we have 3 columns? So 1 of the 3 columns represents 1/3. 1/3 of 6, how many chocolates do we have in that oval? Well, we have 2. Cool? Don't overthink this, guys. Now let's look at 2/3 of 6. So I've circled 1/3 of 6. Now let's circle 2 columns. 1, 2 columns. Now 2 columns. Do you see how that equals 2/3? 2/3 of 6. How many chocolates do we have inside the orange blob? Well, we have 4. Very, very simple, you guys. We're just going to really investigate visually what this looks like and then match it up with our final answers. Let's take a look at a few more here. Next, we're looking at 1/4 of 12. Let's change it up. I'll draw triangles this time. I'm going to draw 12 triangles, and I'm going to draw the triangles in rows of 4 because our denominator is 4. So if we need 12 triangles total and we have rows of 4, how many rows will we have? Well, we're going to have 3 rows of 4 because 4 times 3 is 12. Okay, so we have 12 triangles here. I'm looking for 1/4 of 12. The reason why I made rows of 4, you guys, is because, again, the denominator is 4, and here very easily I can isolate 1 out of my 4 rows, or 1/4. As it turns out, oh no, I pressed that darn button. Goodness. As it turns out, there we go, 1/4 circled, that's 1 column. 1/4 of 12 is equal to, how many triangles do we have in that blob? Well, we have 3. Can we handle that, you guys? What if we needed to look at 2/4? Well, 2/4 would be 2 columns. 2 columns, 1, 2 columns. How many triangles do we have? 2/4 of 12 is equal to, well, I have 6 triangles there. Do you guys know where I'm going next? What if I wanted to learn more about 3 columns or 3/4 of 12. The of 12 means 12 total. 3 columns of 12 is equal to how many triangles? Well, 3, 6, 9 triangles. And then I think some of you saw where this is going. What if I was looking for 4/4 of 12 in the pink? 4/4 of 12. That's actually an interesting question. Well, 4/4 of 12 is 4, 8, 12. 4/4 of 12. You guys, what's another way of saying 4/4? Well, it's 1 whole. 1 whole of 12 seems sort of strange, but 1 whole of 12 is equal to 12. Think about what operation we can replace of with in order to make that statement true. Well, 1 times 12 is equal to 12. So you guys, finding a fraction of something, what we're actually doing behind the scenes is we're actually multiplying the fraction by the whole number. See what's going on here? 1/4 of 12, well, it's 3. That's our first example. Let's multiply 1/4 times 12. What's going on upstairs? Well, 1 times 12, which is 12. And then downstairs we have a 4. 12 over 4 is equal to 12 divided by 4. 12 divided by 4 is 3. Interesting. So this of actually means that we're multiplying. Very, very interesting stuff. Let's take a look at a few more examples here, guys. Okay, I'm going to change this one up to my dear friend, Mrs. Springborn. Okay, let's read this problem. So now we're getting into pretty simple version of a word problem. Mrs. Springborn has 8 apples. She wants to give 3/4 of the apples to her students. She's the best. How many apples will her students get? Okay, let's go ahead and draw the 8 apples. We're going to draw the 8 apples in rows of 4 because our denominator and the fraction that we're going to be looking for is 4. So I'm just going to draw like very simplistic 2 rows of 4. We'll pretend that these look just like apples and not some sort of baked good. So I have 4, 5, 6, 7, 8. So we have 8 apples. I have 2 rows of 4. I chose again to draw my apples in rows of 4 because our denominator is 4. And look what we have. When we are selective with how we set up these sets, I can grab 3/4 very easily. So I'm going to grab 3 columns. 1, 2, 3 columns, because those 3 columns, you guys, represent 3/4. That is 3/4. 1 column, of course, would be 1/4, because you can see these rows consist of 4. We can then identify our 1 column as 1/4 very easily, and then we have another 4th here, 3/4, and then 4/4. What we're looking for, you guys, are 1, 2, 3 columns, which represent 3/4. So we're looking for 3/4 of 8. 3/4 of 8 is equal to how many apples? Well, I have 6 inside that blob. 3/4 of 8 is equal to 6 apples. 1/4 would be 2. 2/4 would be 4. And then, of course, our 3/4 is 8. I hope this is starting to make some sense here, you guys. Very visual. What we're going to work on in class tomorrow is drawing these sets, supporting these awesome visuals with an expression, and then ultimately solving the expression. So let's take a look at one more example. Okay, guys, one more kind of word problem here. Let's look at this. In a class of 24 students, 5/6 are boys. How many boys are in the class? Very interesting. So what we're looking for here, you guys, the expression is we're looking for 5/6 of 24. 24 is our total. 5, 6 are boys. We need to figure out how many boys are there. So what we're going to do is we're going to set up our set. We're going to draw a set, and I'm going to make rows of 6. I need to draw 24. These circles represent the boys. We need 24 total circles. I'm going to make the rows consist of 6 because our denominator is 6. And once we're finished drawing 24 circles, it's going to be very, very easy to isolate 6 in our set. I'm drawing arrows to each circle. Each circle is going to be the top row. And as we add more circles here, you guys, we're going to have columns. So I have 6 so far, and then I have 7, 8. Notice how I'm doing my best to keep everything nice and lined up. 9, 10, 11, 12. Do you guys see how we have columns filling in here? Now we have 2 rows, but I still need more boys. So now I have 13, 14, 15, 16, 17, 18. Great, so you can see very clearly defined columns. I do have 3 rows, but I only have 18 boys so far. We need 24, so it looks like I need to add another row. So we're looking at 19, 20, 21, 22, 23, 24. Great, so these circles represent the 24 boys. I need 5 sixths. So the first column represents 1/6. The second column is also 1/6. Each column, you guys, is sixths. Each column represents 1/6 of 24. That is the case because there are 6 circles in the row. So we can very easily isolate 1/6. So that is 1/6. And now we have 2 sixths, 3 sixths, 4 sixths, and 5 sixths. So I have these kind of strange, they actually sort of look like pea pods now. So now I have 5 sixths circled. What we need to figure out though, you guys, is how many boys are within the 5 sixths. We can do this in a few different ways. I have 5 across and I have 4 rows. What is 5 times 4? Well, that is 20. But let's just make sure that my math is correct. So I have 5, 10, 15, indeed 20. 5 sixths of 24 is 20. Cool stuff, huh? You guys, secret word is that you're going to be checking in on Friday morning. Who in the previous problem, who brought those apples for us? It was a sweet teacher that I adore dearly, and I know many of you were fortunate enough to have her for 4th grade. Who brought the apples for the children in the previous problem? If I went too fast, please think about your learning right now. Please think about your understanding. If this is seeming confusing and if it's feeling like a bit too much, please rewind and watch this again. I need you to come into class tomorrow prepared to practice this. Draw the sets, evaluate expressions, write expressions from the word problems. So all of these things are expected of you tomorrow, of course with support, but think about where you are in your understanding right now, and either rewatch this or just get a great night's sleep and come back tomorrow morning ready to practice. See you Friday, guys.